In this unit, we'll look at extending our check-in processing function to cope with the extra volumes of check-ins we're getting as our application has grown. Recall that our check-in receiver puts check-ins on a stream, and we're getting more and more check-ins, and we have a single instance of a check-in processor that reads entries from the stream one at a time and updates users and location hashes. This isn't going to scale very well with this volume of check-ins because our check-in processor is essentially single-threaded and it's a single instance. And if we were to add multiple instances of it, they would kind of all process the stream entries together and they'd process the entire stream for each instance. So what we would get is double processing of check-ins. What we ideally need to do is a way to build a sort of virtual consumer where several instances of it can collaboratively work together and process the stream between them. So that's what Redis gives us with what's called consumer groups for streams. So here we are going to replace our check-in processor component that was single-threaded and used the xread command with a series of instances of a consumer group processor. So in Redis, a consumer group is something that allows a single virtual consumer identified by a consumer group name to be comprised of several instances of a consumer that work together. And there's a new command for that. So the command for that is xread group. What that's going to do is it works like xread, but we have to tell it which consumer group we're in and what consumer name we are processing as. So we might have consumer 1, consumer 2, consumer 3 are all in a group called check-in processors. Other than that, it pretty much works like xread. So what happens is each consumer in the group is going to get its own logical view of the stream, and Redis is going to track overall progress through the stream, so no two consumers in the same group will get the same message. So let's look at the code for that. We have a file here, check-in group processor.js. That's going to replace our check-in processor, and it's something that we can run multiple instances of. So when we fire it up, we're going to pass in a consumer name from the command line. This is something you'll do in the hands-on exercise. And what it's going to do is not too dissimilar to the old check-in processor. It's going to sit in a while true loop, so forever. It's going to use the xread group command. It's going to identify itself with the consumer group that it belongs to. So which set of instances, and we're calling ours check-in consumers. It'll pass in the consumer name, so whatever we put in on the command line when we started it. So we'll use consumer 1, consumer 2, etc. And similarly to what we saw before, it's going to read one message, block for 5,000 if there aren't any messages around, and it's going to read the check-in stream key. This special ID is greater than is basically saying, get me the next new message. So when we're running in a group, this will be the next new message that Redis has decided is for that consumer. If other consumers get messages in the meantime, then they'll chunk their way through the stream. So this means that messages could be processed out of order versus their order in the stream, because while this instance is processing one, another instance could be processing the next one, and a third instance could be processing the next one, and so on. So we have to think about that a little bit, and we'll come to that. The response from xread group looks a bit like this here. So it's a sort of array of arrays because it can take multiple streams. There's an array per stream. We're only reading one stream. So here's our stream name, NCC check-ins. And then here's our message ID. And then here's our name value pairs for the message. So we have some code that unpacks that into an object, and we get the values out of it. So we get the location ID, the check-in ID, which is the timestamp, and the user key. Then what we had before in the old check-in processor was a load of logic that updated hashes and calculated the new average star rating and all that sort of thing. The problem with doing that in this consumer group model now is that we need all of those operations to kind of happen atomically, and there's some check and set requirements. So we need to see if the latest check-in at a location if the one that we've got is actually newer than the one that already exists, and then update it. And there's now several processes running this. So we need an atomic way of doing that in Redis. So what I've done is I've moved all of that code into a Lua script. Redis has a Lua script interpreter. And basically the way that works is we upload Lua scripts into Redis. It gives us a SHA hash for the script, and then we can call the script passing in parameters and using that SHA hash. So it's a little bit complicated, and we're not going to cover all of it in this course, but what happens is when I do await Redis client.process check-in and pass it the data that it needs, so it needs a couple of keys, the user hashes key that we're going to update, the location hash key that we're going to update, and values from the check-in. Where does this Redis client process check-in function come from? There's some code up here to load the Lua script. IO Redis has this thing called define command that allows us to associate some Lua script with a command name. So I've created a command or a function in IO Redis called process check-in here. It needs to know how many Redis keys to expect when it's passed the parameters. So it knows how many of those parameters are keys and how many are arguments to the script. And then it needs to know where the script is. So I've chosen to keep the script in a file and read it. We'll just really quickly look at the script. This is the Lua script. As I say, it's kind of beyond the scope of this course, but what it does is it looks at its first couple of parameters and says, okay, those are the user and location key in Redis that I'm working with. The other three are the data. And then in Lua, we can do redis.call and passing commands. So I then put the logic to update this in here because I can then do checks such as this. I can basically say, if the timestamp we've got is greater or newer than the one that's currently there, then update it. And as we're running multiple instances of this logic, all of this needs to happen atomically as a sort of transaction in Redis. And Lua scripts run atomically. So we can run this safe in the knowledge that no other instance of the check-in group processor or anything else is going to be messing with these keys between us reading a value and us writing back a new value. So it eliminates a race condition. So the other thing with xread group is Redis tracks which message has been sent to which consumer instance. And this is something you'll look at in the hands-on exercise. So what we need to do once we've processed the message, so once we've run our Lua script, is we need to acknowledge it. So we use the xack command and we say, hey, we've processed this message in this stream. What Redis does then is it takes that off of what's called the pending entries list for this client. So this particular consumer group instance's view of the stream. It says, okay, this instance of this consumer processed this message. We'll consider that the group as a whole has seen this message. And if we don't do that, they'll stick around on that list. And then Redis provides other commands and mechanisms to detect messages that haven't been processed in a long time, or clients have failed to process, and assign them to other clients or do something else with them. That's kind of beyond the scope of this course, but we cover that in the Redis University RU202 Streams course, which I recommend you take if you want to get into consumer groups. So that's basically it for consumer groups. What you'll do in the hands-on exercise next is try running a couple of instances of the consumer group consumer and see how they collaborate to process the stream, and also look at some of the information that's available in Redis for tracking that.